Hello everyone, it's Mike Levin on Thursday, July 14th, 2016. Coming up on 8 a.m. and I am again arriving to work on the early side, planning to get an hour or so of work in before any of the activity starts for the day, and even then continue bear down on my work until the thing I have to deliver is delivered. And like so many tasks in SEO, it has to do with the generation and correlating of multiple lists. And they're not always simple lists. In this case, I have a nested hierarchy that I had actually created by inspecting how things were tagged on the website. And I could tell how things were tagged based on the logging that actively occurs. So if someone adds a tag to a page and doesn't record it in any system, that fact that that tag is on that page starts getting basically logged, like an Apache log. And you can query against this massive table that roughly approximates an Apache log to infer the existence of those tags. And then you can connect that to another table and infer a place that that page exists in the overall hierarchy of a tag hierarchy that helps control serving ads better. Basically, I'm dipping into the data structures that are there for segmenting pages within the site into segments for delivering ads on particular topics. Fair enough. But the hierarchy that results is one of these nested deals. And since really it was, it's like a linked list, every node in the hierarchy sits somewhere with a parent, one parent, and potentially multiple children. It very much resembles the unordered list and line elements of HTML. And in fact, that is how I am rendering the final thing out, so that JavaScript libraries can come in and sort of turn it into an expandable and collapsible hierarchical menu. A lot like surfing directories or little folders on the Mac or Windows desktop. And generating that was difficult, but then that isn't the finished job. Each one of those nodes has to be aligned to a landing page, and the node tree itself has to be massaged with certain elements being removed, new elements being inserted, and every node only really able to show if there is a landing page aligned to it. And when you add new elements to the node, you must add landing page, I guess anchor text, and yeah, those are the two things. Every node needs a URL and a little bit of text associated with it, and knowledge of where it lives in the hierarchy, what its parent is, or what, yeah, I guess it would be what its parent is, so that it knows to sort of flip into existence when it reaches that point in the hierarchy. So I'll be combing together essentially a list on the left and a list on the right. These types of things are, variously called joins. Let's see, I guess it really is just a join, but in Excel terms, a lot of people would do a VLOOKUP. A VLOOKUP is just a fancy way of doing a join where the particular technique is a very implied by the name of the function, which is probably not a good thing, because if it was a true VLOOKUP, it would not be highly optimized with every entry on a tabular table potentially having to do a lookup against a whole nother table. And I guess that kind of thing can be fast if it knows it's doing it ahead of time and optimizes for it with some sort of execution plan and creation of temporary objects for fast lookups like hash tables. And you get the advantage of Python when you do this in an environment like Jupyter Notebook, which not only gives you the advantage of Python, but gives you the advantage of persistent variables as you execute through your code, and the ability to sort of jump around and re-execute things, clear all memory if you need to wipe it clean and restart it, but to oftentimes re-execute your queries or your process from the middle, knowing that you don't have to re-execute that big SQL query up there, and the object you need in memory is just really sitting there and hasn't gone away, so it actually saves a lot of work on the back end. You're not as demanding on the server resources you're touching, because your data stays persistently cached locally until you re-execute the script from the very start again, and it has to pass through that part. And let's see. So the correlating task. My video, my talking head coding video, probably won't be first thing this morning because I actually have to do this work urgently. But it will be later today once I'm clear of the meetings that I have to attend. And I'll probably demonstrate the thing that I've actually done today. It'll be a after the fact. Here's some interesting tricks you can do with ordered dictionaries, for example, and adding and deleting nodes from trees as you walk them, or before or after you walk them, because an interesting thing is you can't necessarily change the node structure of an object while you're iterating through it. I had recently learned. So if you have a arbitrarily nested object and you want to delete elements from it, the way to not do it is to walk the object tree and try and delete them when you encounter them. You want to know its address and just address it directly with a delete or a pop or whatever method you're using to remove it. Conversely, I'm going to have to insert elements into the tree. And because it's an ordered list, I need to figure out how to insert them at a particular location. And also, I need to come up with an addressing system with the lists on one of the sides, the flat list that's getting combed into the hierarchical list. So essentially, I either need to spin through the flat file, inserting things that it finds that belong in the hierarchy into the hierarchy, or I need to spin through the hierarchy and look for the places where something is supposed to be pulled from the list. I'll probably walk through the flat list and dynamically insert into the object structure. Now the object structure, interestingly, this ordered dictionary is something that I had to import from the collections package that comes with core, so you don't have to pip install anything. And the collections package is full of all kinds of nifty things, including named tuples, which I will be doing a video about soon, but this is not it. But another one is an ordered dictionary, which API-wise, you use it, you interact with it just like you would a normal dictionary, but you can sort it for starters. So if you need it alphabetical to control, say, for example, menu hierarchies, you can. And I'm assuming I'll be able to insert things into the middle. I'll be able to use slicing techniques. The tuples themselves, because it appears to be a list of tuples. So when you print the string representation by just, outputting the ordered dictionary with a print statement or just typing the name of it on its own line in Jupyter Notebook, and execute that, you will see something that looks exactly like an outer list, and inside that list, a series of tuples. First item in the tuple, in each tuple, is the key that you're familiar with, the key that you were doing the lookup before it. But then the second item in the tuple is a dictionary. So an ordered dictionary is a list of tuples, with each tuple being two elements and the second element being a dictionary. So this implies one sort of API that you should be able to like reach in and address that key with a numeric index, because it's the first item in a list of tuples. So you would think you could name the tuple with square brackets to address it with a number representing its position. Now you actually have to use the word that's in the first position of the tuple. So an ordered dictionary is overriding the default API of the data structure that the string representation applies, providing an API that is much more like a traditional dictionary, so that when you use an ordered dictionary, it feels like you're using a dict. But I'm going to have to find a way to understand the numeric index of an ordered dictionary, so that I can do things like insert from the middle without repeating myself. So I'm going into work to quickly figure out how to do that, to quickly implement against it so I can start flowing anchor text and Ahref links into my unordered list hierarchy, so that you can not only expand and contract or expand and collapse the menu, but you can click on an element and open a page, and that there's a series of overrides of the default hierarchy that gets created. One to scrub out all the unwanted nodes, and one pass to insert the new nodes, and then another pass to insert everything from list B, the flat list, into list A, the hierarchical one, so that every node has a landing page associated with it. And I'll probably implement it as some sort of filter, so that when the nested structure is walked to output the HTML, it will only do so for those elements that have anchor text and a landing page. Otherwise, it's not on the menu. So there's sort of a filtering process here too. So the menu starts out very small and then grows big as I let things poke through. Concepts like that are always reoccurring in programming and information system stuff. That would be deny all by default, and then have some sort of allow set filters. The reverse is an allow all, and then cutting things off, which is obviously less secure. And the thing I don't want happening is people opening these expandable menus going, that doesn't have a link, that doesn't have a link, that doesn't have a link. I want them going, oh, that's smaller than I thought. And I'm like, yeah, just imagine it in your head as something that will grow larger every time we identify something that belongs there, shall I say. For reasons that I may or may not elaborate on future videos. And so I'm at the office now. I hope I'll make one of those talking head Python Jupyter Notebook videos for you. If I do, I'll see you there. Thanks for joining me, and don't forget to subscribe.